For lesson 7.3, we're going to be looking at the chemical properties of substances. So chemical properties can only be observed when the matter is changed into a new or different substance. So two of the main things that we can look at as far as chemical properties are flammability, so the ability to burn, how quickly a substance will burn, and then reactivity, so how readily a substance combines chemically with other substances. And so we have chemical indicators that let us know that a chemical change is occurring. So one of them is that there is a change in color, and note that it means that there's a new color that's occurring. Okay, so if I take red food coloring and add it to water and the water turns red, that's not a chemical change. Okay, my one substance was already red, and when I added it to water, it just turned the water red. They didn't chemically combine. So it would be adding two colors and then getting a completely different color. And so we'll kind of talk about that when we talk about the examples below. If it produces gas or bubbles when no heat is applied, okay, so if you think of like vinegar and baking soda, when you mix those together, they foam up and create a lot of gas and bubbles. That is a sign of a chemical change, okay? Notice that there's no heat applied. If something is bubbling because it has heat applied, that is not a chemical change, okay? That's just a phase change, which is a physical change, meaning it's changing from a liquid to a gas. So the next is a formation of a precipitate, which is a solid. It's just another word for a solid. So if we were to mix two liquids together and it creates a like substance, either like a solid or kind of like here, there's kind of an example of a precipitate being formed. That is an example of chemical change. If it produces light, so for example, if you've ever broken or cracked a glow stick, there's two different liquids that when you crack it, it basically mixes those two liquids together and they go through a chemical change and it produces light. And then also a change in temperature when two substances are mixed together. So if the energy is released and heat is lost, meaning that it's going to feel like it's getting warmer, it's going to be exothermic. But if it's absorbing heat, absorbing energy, it's going to feel like it's getting colder. It's an endothermic reaction. Okay. The physical change indicators, there's not as many as we see with chemical change, because physical change, it's basically going to change shape. It's going to have the same chemical makeup. So if I tear something or cut something, crumple up a piece of paper, those are all just physical changes. They're still paper. It's still wood. It's just that I've changed the shape of them. Okay. Also, changing state is just a physical change. So if it goes from gas to liquid to solid, it's the same. So if we think about water, if I have liquid water and I freeze it, it's still going to have the same chemical makeup of H2O. It's just now in a different state. Okay. It is reversible. It can go back to a liquid by melting. Okay, so that's why it's not a chemical change. It's not changing its chemical makeup. So if we look at all of these images down here, there's different examples of either chemical or physical change. So here we have an egg, and so if you know what an egg looks like before it starts cooking, okay, this is clear generally, but now since it's been cooking, you'll notice that it is now white. So there has been a change in color. Right? It was clear, now it's white, so there's been a change in color. This also goes from being a liquid to a solid, so it's actually forming a precipitate. Okay, so that's how we can see that it is a chemical change. Here we have a nail, okay, and then we have rust. So you'll see the nail was once just all silver or gray, and then now we have this material that's built up on the outside of it that is a new color. So we have a change in color, and we also have a formation of a solid on the surface of the nail. Okay, for this next one, we have a clear substance going into another clear substance, and then it comes out with this kind of smoke-like looking yellow substance. And so again, we have a change in color and a formation of a precipitate. Okay, here we have baking soda and vinegar, and when we add them together, it's going to produce bubbles without heat. So that is formation of, produces gas and bubbles, so we know it's a chemical change. So all 5 of these have been chemical changes. For this one, we have green paint, and we paint the wooden siding. Okay, the wood is technically changing color, but it's not a new color. Okay, the paint was already green. Whenever it's added to the side, the paint is still paint. The wood is still wood. This is just a physical change. Okay, and then boiling water here. The water is not changing into something different. It's just changing into water vapor. So it's still water. There is bubbles, but heat is being applied. So it is a physical change because it's just changing from liquid water to a water vapor, which is a gas.